Hello students, welcome to the first online tutorial for the academic session 2021 and 22. So we will begin with chapter number 1, number system. And in this chapter, in today's content, we are going to discuss the decimal number system and binary number system. So we all know that in the earlier times when there were no means of counting, people used to count with the help of their fingers, with the help of pebbles, stones, and sticks. But these methods were not adequate and it had many limitations or disadvantages. So, to overcome this limitation, many number systems were introduced as the time passed by. So, among them, this, we will discuss in this chapter about the decimal number system, binary number system, octal number system, and hexadecimal number system. But for today's content, we will just go through the conversion of decimal number into the binary number and the conversion of binary number back into decimal number system. So let us begin. Decimal number system. So it consists of 10 digits, that is 0 to 9, means 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So if you count the digit from 0 to 9, it consists of 10 digits. So we can call that the decimal number system has a base 10. Suppose if you see the example here, 120. So 120 is a decimal number and it should have a base 10 because this 128 has been made by any of the number between 0 to 9. Now each number can be used individually just like 1, 5, 9, or it can also be used in groups to form a numeric value, and it can be a negative value, that is negative integer, or it may be a value with the decimal numbers. Now the next is binary number system. So we have also learned this one in the previous class, that the binary number means it consists of only two digit, that is 0 and 1, or what we also can call it as a machine language. Okay, so since this system use only two digit, that is 0 and 1, so it has the base 10. All digital computer use this number system and converts the input from decimal format into its binary equivalent. Means why binary? Why should we use a binary number? Because we all know that the computer cannot understand human language. It does not understand the English alphabets, it does not understand the mathematical numbers or any kind of symbol. So whatever we enter into the computer, whether it is English alphabets or whether it is a number, all needs to be converted into a machine code, that is 0 and 1, because computer understands only the binary code. Therefore the data that is entered into the computer is to be converted into binary equivalent, and once the computer understands what exactly you entered, so it will be further converted back into the digital decimal number, so that we can understand. Now first let us go to the conversion of decimal number system into the binary system. So I am going to show you how the decimal number system can be converted into a computer number system or a machine number system. So these are some of the points that you need to understand, or you need to remember rather. First is, we have to divide the given decimal number with the base 2. Now after that we have to write down the remainder at the side, and again we have to divide the quotient by 2. Means we will repeat the step 2, that is we will divide the quotient again and again by the base 2 until and unless the quotient becomes 0. So remainder which are obtained in each steps are written in the reverse order to form the binary equivalent of a decimal number. So let me show you this one with the help of an example. So let me take one decimal number. Suppose say the number 25. Now I will show you the equivalent binary number of this decimal number. So according to the steps that we have gone before, we have to divide the decimal number with the base 2. So let me divide it with the base 2. So if we divide 25 with 2, so we will get 12 as a quotient and 1 as a remainder. So what we will do is, in the next step, again we have to divide the quotient by the base 2. So let me write this 12 here, and let me write the remainder, that is 1, at the right hand side. Now what I need to do is, again I have to divide this quotient by the base 2. So it will be 6. The next quotient will be 6. 2 6 the 12, and the remainder will be 2, will be 0. So I need to repeat this step again and again until and unless my quotient becomes 0. So again I will divide this quotient with the base 2. So it will be 2 3 is 6, and we will get the remainder as 0. Again I will divide this quotient by 2. So it will be 2 1 is 2, the remainder will be 1. And again I will divide this quotient by 2. So it will be 2 0 is 0, and the remainder will be 1. So finally my quotient is 0 here. Now what we can do is, we have to arrange this number in reverse order. So all these decimals should be arranged in the reverse order. That is, from the most significant digits it should be on the left hand side, and the least significant digits it should be on the right hand side. So we call this as the most significant digits, and we call this as a least significant digit. So we will arrange these numbers, that is the remainder, in reverse order from bottom to top. So we can say that this 25 is my decimal number. Let me give the base 10. So the equivalent binary number of 25 is 1 1 0 0 1, and we should put it inside the bracket with the base 2. So this base 2 denotes that this is the binary number, and the base 10 denotes that 25 is a decimal number. So the equivalent binary code, that is the machine code for 25, is 11001. It means when you enter the value 25, if you give the input 25 to the computer, so you know that the machine computer doesn't understand 25. It should be converted into the form that the computer understands. That is the binary digit. So it will be converted back into 11001. Now, as we all know that, again, if we may not understand what actually 11001. So to show the output, this 11001 will again be converted back into the decimal number 25 as an output, so that we can understand. So let us go with another example. Suppose let me take one decimal number, that is 321, and let us see what will the equivalent, say the machine code or a binary number of this decimal number 321. So to begin with, the first step is we need to divide the number, that is decimal number, with the base 2. So once we divide it, so let us check. Suppose say if we divide 321 with the 2, so we will get 2 1 2. It will be 2 6 12. Okay. The next number will be 1. So 2 0 0. So 160 is my quotient and 1 is my 0. So what I need to do is, I have to write the quotient here, that is 160, and let me write the remainder as a side. So the second step is, I have to divide this quotient again by with the base 2. So if I divide this quotient with the base 2, I will get 80 as a next quotient, and my remainder will be 0. So we need to follow, or we need to repeat the step number 2 again and again until and unless my quotient becomes 0. So again, if I divide this quotient by the base 2, it will be 40, and again my remainder will be 0. Next, if I divide 40 with the base 2, it will be 20, my remainder will be 0. Again, if I divide this quotient with the base 2, I will get 10 as my quotient, and the remainder will be 0. Again, it will be quotient will be 5, the remainder will be 0. So if I divide this quotient again by 2, it will be 2 2 4, and remainder will be 1. And if I divide this quotient again by 2, it will be 2 1 2, remainder will be 0. Again, if I divide this quotient with the base 2, so it will be 2 0 0, and the remainder will be 1. So finally our quotient comes 0. So after that, I have said that this is the most significant number, and the one at the top is the least significant number. So let me give the arrow in this way. So what we have to do is we need to arrange all this remainder in the reverse order, that is from bottom to top. So the equivalent binary number for the decimal number 321, it will be, say, 0, next is 1, after that again 0 0 0 0 0 1. So it will be 0 1, then 0 0 0 0 1. So we can say that the equivalent binary code or a machine code for 321 is 0 1 0 0 0 0 1. Okay, so always remember, don't forget to use the base here. This 10 denotes that this is a decimal number, and the base 2 denotes that this is a binary number. So I hope you have understood it, how to convert the decimal number back into the binary number. So in our next video, I will show you how to convert the binary number back into the decimal number. So this is all in today's video. Thank you, students.